In the last video, I've talked about how we can make a circuit in which we can switch a light on or off automatically when the sun comes out or when it goes dark. Now in this video, I want to talk about a very similar circuit which can switch on a fire alarm when it gets really hot. We have a battery here as before. I suppose that this is connected to fixed resistor, and then we have another resistor here that is sensitive to temperature in a similar way that the LDR was sensitive to light. And the idea is that if I take a voltage out from across this temperature sensitive resistor, then when it gets hot, when there's a fire for example, hopefully this resistance would change, and then somehow a fire alarm that's connected between these 2 points would switch on. Right, now let's think about how this might be possible. In a number of videos ago, I've talked about something called a thermistor. If you remember, let's see what a thermistor looks like. Kind of looks like there are many kinds of thermistor. I think I've previously drawn one that is sort of consists of a small piece of thing with 2 wires sticking out from it. Okay, and I call that a thermistor. The thermistor is basically a resistor that is sensitive to temperature. Now, and I've also drawn a graph of the resistance against temperature previously. Just a very rough sketch. The resistance against temperature. And let's say the temperature range is from, say, 0 to 100 degrees Celsius. And again, it depends very much on the model, the manufacturer of the thermistor, but typically, at least for those that are commonly used, the resistance can vary over a wide range. So I'm just going to say, for example, that at 0 degrees Celsius it's 100 ohms, and at 100 degrees Celsius the resistance could fall right down to maybe 1 ohm. Okay, so suppose that's how the graph looks like, some kind of a curve in between. Okay, so we now have an idea of this special resistor whose resistance change by a factor of 100 times over this temperature range between melting ice and boiling water. So what we hope is that when it gets hot, I can make a circuit that triggers a switch on a fire alarm. Now if I use it here, now let's briefly recall what I did with what we did with the lighting, the automatic lighting. I had an LDR here, and In the dark, when it was in dark, the LDR resistance was very high. And that gives a big voltage across here, and that switched on the lights. So when this voltage is high, when this resistance is high, this voltage is high. Now in this case, the thermistor resistance is high when it is cold. So when it's cold, this voltage is high, and it will trigger off the fire alarm. No, we don't want that, do we? We don't want that. We want the opposite. We want the fire alarm to be on when it's hot, not when it's cold. Okay, so putting a thermistor there would not work. So I tell you what I'm going to do. I'm going to put the thermistor there instead, right? That surely would reverse the ordering. Okay, let me try that. Now there is a circuit symbol for thermistor. It looks like this. A rather strange looking symbol. So a short line and another slanted line through the rectangular box. So that's my thermistor. And just for example, I'm going to put in some values. Let's say this is a 1.5 volt battery. It's probably not strong enough to switch on a very loud alarm, but I'm just going to perhaps imagine having maybe just a small, just a soft alarm, maybe just a buzzer that sounds, just for our little exercise here. So I have a little buzzer here that can make some sound when it's switched on. Okay. Right, and so this time I'm going to put a fixed resistor here. I'm going to say maybe it's a 10 ohm resistor. Okay. So I think we are all set. To go. So let me start by calculating the voltage across here. I'll call it V2. And I'll call the voltage across the thermistor V1. Okay. I want to know, I want to find the voltage of V2 when it is hot and when it is cold, so that I know whether it will switch on. I know whether the voltage will be high when there's a fire. Okay, so let me start from when it is cold. When it is cold, okay, I want to calculate V2. When it is cold, the thermistor resistance, for this example, I'm going to take it as 100 ohms when it's cold. Okay, so that's 100 ohms there. Now, if I want to calculate V2, voltage across the alarm, the ratio of V2 to V1, those two voltages, is equal to the ratio of the resistances, 10 to 100. So that's 1:10. I can now calculate V2. V2 would be, so V2 is 1 part out of 11 parts, so that would be 1 over 10 plus 1 times the full voltage across both resistors, which is 1.5 volts. Now again, I just need a rough answer for my example. So I'm going to say, okay, 10 is a lot smaller than 1 is a lot smaller than 10, so the bottom is roughly 10, and I have 1.5 over 10, and that gives me roughly 0.15 volts. Okay, so I have a small voltage. I have a small voltage when it is cold. So the alarm will probably not switch on, or it will be very, very soft. It's not going to alarm anybody. So okay, so I'm just going to write, because this voltage is low, the alarm will be low or off, roughly speaking. Okay, what happens when it's hot? Say when there's a fire. When it gets hot, the temperature, right, the resistance of the thermistor comes down. Now, just for example, I'm going to take the temperature to be 100 degrees Celsius. Well, that's very hot if your room is 100 degrees Celsius. Maybe not as hot as a fire burning directly in the room. So but I'm just going to take this temperature to be 100 degrees Celsius. Then the thermistor resistance, for this example, I take it to be 1 ohm. Okay. So I'm just going to cross out the two zeros there. I'm just going to have a 1 ohm resistor here. This time, the ratio of V2 to V1 is equal to 10 to 1. So I have the ratio reversed now when it's hot. Therefore the V2 voltage I can calculate. Now V2 is now 10 parts out of the 10 plus 1 parts in the ratio. So V2 is 10 over 10 plus 1 times the full voltage across the two resistors of 1.5 volts. 1.5 volts. Okay. And I just need a rough answer just to illustrate my point. So I'm going to say the bottom is close to 10, right? 10 plus 1 is close to 10. So 10 over 10 is 1. Therefore, the answer is about 1.5 volts. So now I have the full voltage of the battery across the alarm. So therefore, I can conclude that when it is hot, the alarm will come on. So there I have a working fire alarm.